Okay, hello everyone. Welcome back to the second video of second order differential equation for MA 1203 Business Mathematics 2. And in this video we will learn about one application of second order differential equation, which is for price adjustment model with inventories. Okay, so originally we have learned about the price adjustment model, right? So the price change, the price change is proportional to the supply demand gap, So we have, if we have QD is the quantities of demand and QS is the quantities of supply, the supply demand gap will be this one, quantity of demand minus quantity of supply, and this is proportional to the change of price, so there will be a positive constant here, right? Okay, but of course here in this model we neglect the inventory of unsold merchandise, because of course there is a possibility that the merchandise being supplied will not be sold, right? And that arises when we have excess in supply. Okay, so now if we have a downward pressure on price when there is an inventory, so the price will go down when there is an inventory, and it is proportional to what? To the number of inventory, So if there are a lot of inventory, of course the price will go down further, right? So this is our original model, so we put it here, and it will be minus, so this one will go further down because of the inventory. And how to count the inventory is the inventory is just the gap between the supply and the demand, so we subtract quality of demand from the quality of supply. But when do we do this? We do this for all time before t, so that's why we integrate from 0 up to t. Okay, so we have this one, and of course here we only have the first order first derivative, and to get the second derivative we have to differentiate both sides, so we take derivative of this one, it will be p double xn. If we take derivative of this one, alpha is just a constant, but this one we take derivative of qd and also derivative of qs, right? And then this one, if we take derivative of this, by the fundamental theorem of calculus, of course it will be equal to what's inside, so beta times with what's inside, qs minus qd. All right, so if we have the quantity of demand is this one, as usual it's just linear in terms of price, and then the quantity of supplies is another linear equation of in terms of price. Then if we substitute both qd and qs here, and we take integration, we take derivative also for this one and this one, we will get this one, right? This one is qdxn, so it will be a, this is a constant, if we take derivative it will be 0, bp if we take derivative it will be bpxn, minus qsxn. Qsxn will be what? The derivative of f, this is a constant, will be 0, the derivative of this will be gpxn, minus, we just substitute all of this in here, right? Okay, if we do some readjustment, into the general form, we will get this one, p double xn plus this one times p xn, this one times p equal to this one, so you can recognize that this is a second order differential equation, linear, let's see, p double xn, p xn, and p all linear, uh, autonomous, yeah, without variable t explicitly, yeah. And of course, you can find the solution for this second order differential equation, yeah. For instance, if we have alpha, beta, g minus b, a minus f is equal to this one, and I will rewrite, yeah, the what the general form, yeah, of the price adjustment model here, this one. Of course, you just have to put in back, yeah, or you just have to substitute back the alpha, the beta, and the g minus b and the a minus f, right? Yeah. Okay, if you put that all of the constants there, yeah, g minus b is 20, alpha is 0.25, and so on and so forth, you will get this equation. If you simplify, of course, you will get this second order differential equation, yeah. And how to find the solution? Of course, find the homogeneous solution first, yeah. This is the homogeneous equation with 0 on the right hand side. What is the characteristic equation? That will be r squared plus 5r plus 4 equal to 0. And of course, you can factorize this and get the roots. The roots will be what? This is going to be r plus 4 times r plus 1. So the roots will be minus 4 and minus 1. And the solution will be c1 e to the power of minus 4t plus c2 e to the power of minus t. Remember, these are two different roots. Alright, so what about the particular solution? Remember, this is the original equation. The particular solution will be equal to the steady state value, which is 20 over 4, right? And it will be equal to 5. Okay, so the general solution will be the homogeneous equation plus the particular solution, and we just copy this one into here, plus the particular solution, which is equal to 5. Alright, so that's one application of second order differential equation. And the second topic is the steady state and convergence, yeah. Yeah, so when will the solution converge to the steady state value, right? Okay, so when we have two distinct roots, this is the solution, right? The homogeneous solution plus the steady state value, or the particular solution. And if we take limit of t approaching infinity for yt, of course we take limit of this one, yeah. When will this value will it be equal to the steady state value? Of course, when both of these are 0, yeah. When will this be 0? Yeah, of course, when the power of e is negative, yeah. When this is negative, when this is negative, yeah. So here, yeah, yt converges into y bar if and only if we have this one, yeah. Both r1 and r2 is negative, yeah, less than 0. But because when all of these r1 and r2 are negative, this one will convergence to 0, yeah. It will approach 0, yeah, this limit. So in particular limit. Okay, what about the roots are the same, yeah? r1 equal to r2 equal to r. Of course, we have this solution, remember, yeah? We multiply the second term with t, yeah? And if we take limit t approaching infinity, yeah? The same question, yeah, is when will this limit will be equal to y bar, yeah? Will be equal to the steady state value. Of course, when all of these are 0, yeah? So when will this be 0? Of course, when r is less than 0, yeah. When r is negative, yeah. When this is negative, this will approach 0. When r is negative, this will approach 0 also. Okay, so these are the two properties, yeah, when the solution will converge to the steady state value. Okay, so if we go back to the example before, yeah, can you decide whether this will converge to the steady state value? Yeah. Okay, so remember the roots are what? -4 and -1. So whether do you think the solution will converge to the steady state value? Yes, yeah, because both of R1 and R2 is less than 0. Okay, so that's the second video, and see you again in the next video.